are very pleased to be back here with you at Xylexpo. We already participated in representation of wood quality group in Xylexpo other times, and it's a pleasure to be back here at this exhibition. We attended the inauguration ceremony yesterday, and this exhibition, as all Italian companies and realities, has a value whenever it becomes an historical appointment. Xylexpo was first established back in 1968, and it represents the cradle of Italian technology, and not only that. Exhibitions have evolved and they have adopted an international fair, and so has Milan's trade fair too. So we have representations of local domestic companies and international companies too. Yesterday, during the inaugurations ceremony, we learned that this is a very specific industry niche, and this niche is well represented by Xylexpo exhibition. We learned that there are 5,000 niche manufacturing sectors worldwide, 5,000, 1,000 of which are Italian, and one of them is the woodworking technology sector. So it is very interesting to understand how Italy is positioned in this market niche, and it is interesting to become aware that this niche really values our business world, businesses, as reminded by the Councillor of the Region of Lombardy for University Research and Innovation. And it values the fact that although we do not produce raw materials, Italians are good at using their hands and minds and also their hearts, as suggested by the audience. And so we are always at the cutting edge in this respect. Another strong message that was conveyed yesterday is that Italians and whoever deals with technologies and these niche industry too are required to aim at quality, because quality is what differentiates us from other booths that are here present, but they can also be our competitors. This is the context where we are now together with the representatives of Gruppo Qualità Legno. This group set up its association after 10 years of establishment, and its payoff reads knowledge, innovation and mastery. Three key words that try to express the real meaning of and purpose of GQL, this to say quality in doing and building with timber. And this is not a banality. I was reading a few days ago, as I prepared for this conference, a sentence by Emilio Ambaz, who was the precursor of a concept that nowadays is very much used, actually overused and abused. He was recently awarded at the Politecnico di Torino for being the father of green natural architecture, when nobody would mention this concept. I can't find a quotation in my notes, unfortunately. We all speak of green architecture nowadays, but he started working on this many decades ago. I can't find the note, so I will read it to you later. Never mind. So in representation of GQL, Gruppo Qualità Legno, we have here the newly appointed president of the association. That's Professor Architect Davide Maria Giachino, who was designated last year when the new board members were voted and elected. And then we have two other board members, Engineer Marco Arata and the specialist in wood diseases, Mr. Gianfranco Magri. These are the speakers for today's agenda and for the next hour or so that we will spend together. And we will try to address the topic of quality and the meaning of quality in building with wood and timber. It's not such a banality in terms of emission. Um, Construction timber is a relatively new area of business opportunities. If we think of engineered timber that is available today, this is a relatively young sector, and as all young sectors, there is still a long way to go and to cover. This association, Gruppo Qualità Legno, was established exactly for this purpose, for the purpose of creating culture in the area of construction timber, and first of all in the wood niche industry that I've been dealing with for almost 25 years, but it's still very exciting for me to do so. So coming to today's topic and to today's speeches that will be delivered by our three speakers, the focus it has been placed on something very specific. We participated in other conferences speaking about construction sites and the relation with the available technologies. But this year's focus is on the real connection with digital technologies. Even numerical control machining centers have a great orientation to developing their software parts. There is Xylexpo Digital as well as Xylexpo physically taking place here, and this is the proof of what I just said. We are recording a conference that will then be broadcast on digital platforms. So this is the sense of our work. So the digital language in a construction site. So what kind of implications does it bring about, and what future opportunities will this represent for architects and engineers that attend construction sites every single day? Let's start addressing this topic together with the professor and architect Davide Maria Giachino. He has two souls. When we speak, he is either riding a bike and going to a construction site, or on a train heading to a construction site, or he may be at the university lecturing his students and also touching the wood, that it's such an original material that always is connected with the pleasure of being touched and known through all our sensory systems. So going back to today's topic, I would like to ask Professor Giachino what is the meaning of his lecture on local design and building global. I give him the floor. Good morning, everyone. Thank you for the invitation, and thank you, Sonia, for this very nice and cute introduction. So, local design and global building. Why? Because the design process has been changing. 10, 20 years ago, it was not possible to just work in this way. Nowadays, planners, designers who opted for advanced digitalization are able to design their structures anywhere in the world. Let me mention a colleague of ours, engineer Piva from the Ergo Domus design studio. Right now, from a small scale studio located in Pergine Valsugana, a small town, he can design and make projects worldwide, despite being located in scarcely known place or location. Not many engineering or design studios have made this choice. He opted for this very much driven, the digitalization driven type of design process. I like his expression of considering wood digital material, which kind of clashes with the image and reputation of wood that we have, that we always associate with something vegetal and certainly not digital. When you're sitting in front of your computer, faced with your monitor, the object that you can view on the monitor will be exactly the piece of wood that you get on the construction site. So if you get something wrong by a few millimeters in your design process, you will end up having the wrong piece of wood on the construction site. And I know that it doesn't seem such a big thing because in the building industry we've always accommodated the tolerances from 0.5 centimeters and above. But in the world of wood, even 10 millimeters has a value. Let's imagine a multi-floor or multi-story building. In North Europe, they are designing 20-floor buildings, and if you get it wrong by 10 millimeters per each floor, the connections will then not be able to function properly. So it's a difficult process that still demands a lot of attention and care. There are still limitations. The pipeline is not all consistently digitalized. We have engineers, we have architects in the construction sites, but we also have engineers that only deal with wood structural elements, engineers that only focus on steel and reinforced concrete. So 2 or 3 different people that deal with the structures. Then there might be operations management managers and supervisors. Then there are other specialists, like facade specialists. Nowadays, the outer shell is very relevant, and there are designers that only focus on a shell, and so, like Arup, for example. So many different players, but the degree of digitalization of these players is not the same for everybody. It's inconsistent, and so sometimes the pipeline gets stuck or slows down, and so you have to downgrade to the lowest degree of digitalization. I think this is a current limitation of the system. However, I believe that in the near future this system will be increasingly widespread and these gaps will be breached. So let's carry on with a focus on this topic of the construction site with engineer Marco Arata. He devised a report which is available for further insight, and this report is about the beginning phase of the first passive houses, the first timber construction. It's an interesting conversation with him because he is a testimony that can explain to us the impact of numerical control technologies on low energy consuming houses when digitalization was not yet there. Well, if I may just tell you a personal anecdote, the agency Casa Clima, established back in 2002, delivered the very first training on passive houses or timber constructions, and they were the only professionals available to do so. We would see the images of log homes with wedged corners, unbarked beams, rounded logs, things that Andrea Zenari in his wood factory is still implementing nowadays. And we were surprised by the block houses. We would see these houses with visible facades, visible wood-made facades, with millimetric precision joints and mortises, and we were really overwhelmed and extremely surprised. So our question was, but do you have sawmills that are able to develop our project with that degree of precision? Back then, we were only familiar with traditional sawmills, so we would buy just the roof made with longer beams than necessary. We would use chainsaws in the construction site to cut them, and then we would use nails to put things together. and it was like a trade fair. They didn't know what screws were or fasteners were. So this was the situation back then. So to us, a timber construction was the house that you would see when you go out skiing in Val d'Aosta or in Trentino, or farming houses with a modest demand, low performances, structures that had no durability except for some eccentric individuals that would make their own wood or timber houses, but again durability had not been addressed by anyone professionally, and so after 10 or 15 years those houses didn't look in a good shape. And maybe they're still standing up, but again they don't look nice. So, and in those years, Casa Clima began to show us these things that were these projects. We had never heard of the concept of forced mechanical ventilation or isolation materials such as foam glass or other cellular insulation materials, but the market already had them. The first passive house was built in Darmstadt in 1991 by Wolfgang Feist. He made it together with his wife. It was basically used as a community, a Wohngemeinschaft, as it was the trend back then in Germany. And then the passive house protocol was developed with Professor Adamson from the University of Lund in Sweden. Everything was there. We didn't know how to use them. In the region of Trentino, they were much ahead of us, more than 20, actually 30 years have gone by. My colleagues and I were first impacted by it. Now the situation has improved remarkably. Numerical control sawmills are available throughout the national territory. They have technical department and they are able to support us. And design studios like ours can use 3D design softwares that are very user-friendly. We use a SketchUp. We can make our own 3D design. We then obtain a packing list, which we submit to the sawmills that then translate the packing list into pieces through the work of their own technical department. Designers are very well supported. They have possibility to learn these new techniques wherever they want. Sawmills have benefited from a large investment to get equipped. But the missing ring of the chain still is the labor force in the construction site, the assemblers, the builders. You can be as precise as possible in your design. The sawmill prepares precise and accurate pieces, but you cannot rectify errors made by the labor force in the construction site. And so labor force are no longer prepared as it used to be in the past, where junior employees were buddied by the seniors and learned how to do that. Now we can offer training for artisan businesses. We teach them what to do and we teach them about the relevance of the care for details for passive houses. Things need to be done with care, because otherwise the other steps of the process will be missed, and then we end up in a situation that like that of the eccentric houses. There's one new important principle that we have to come to terms with, and that is the repeatability, consistent repeatability of a project. Once you have the packing list, you can send it to 10,000 different sawmills and you can replicate it 1,000 different times. This is helpful when you have to cope with emergencies. Given Italy's geology and geological situation that hasn't been taken care of for many decades, we are often exposed to flooding and earthquakes. Legislation had forgotten about it. We've realized it, unfortunately, in recent times. So when there is a need to build many houses over a short period of time and transport them and mount them quickly, we can rely on a ready-made project that can be distributed to 1,000 different sawmills with the same assembly scheme. It has lightweight, and in Italy in 2009 we missed a great opportunity in Italy with the earthquake in Aquila. Uh, some projects have been sponsored to build houses with big steel pillars on top of which a capital with some insulation devices were mounted, which they were described as an excellence of the Italian technology, but I don't think not a piece of it was exported. So the insulation system was definitely not an excellence, and any engineer would not have been able to keep those houses standing. They were hyperstatic. Durability was poor and scarce. Balconies would fall off. So if we had opted back then for timber houses, maybe we would have run out of timber, but we would have used the opportunity to come up with timber houses, which would have pushed the timber industry. We would have left energy efficient houses that could be classified as an A4, so energy efficient houses. And this means comfort. We would have left a high living comfort houses. So in short, this type of construction offers three main properties and qualities: speed of execution. Machines are able to replicate, to duplicate these houses at a fast speed, as if they were small chocolates. Earthquake proof is the second benefit. A timber house has a weight that is 1/3 of a traditional house, and this already provides a better response. Wood is not by itself earthquake proof, but the joints and the joinery it is made, the fastening systems is made with are earthquake proof. And finally, third quality is the thermal performance. The lambda is 0.13, which is not insulating, it's not conducive. However, it's the construction material that has the highest insulation property that we can use. And some say that we could use straw, but straw is used for the padding, but the structure needs to be made in wood. And I met a sawmill owner once, and he said, "What are they doing houses with straw nowadays? Are you happy? I brought a truck full of wood." So last but not least, the requirements to make a good wood-based houses coincide with the same requirements of a passive house. So you need to be very careful and create a double boundary of airtight system along the entire outer shell. And you have to do that with a good insulation material so that you can prevent drafts whenever there is a joint between the roof and the wall, around the windows. And why is that so important? Because drafts disperse energy, and we want to avoid heavy dispersion. And then drafts also allow vapor to flow through, and this may lead to rottenness. So as you design a well-made wood-based house, you make a passive house, a comfortable house. So numerical control technology is exactly what we need to make good higher energy and efficiency buildings. Thank you, Engineer Arata. You've been very comprehensive and clear in this journey from the concept of passive house, wood house, to the construction of the house on the site. We're going to resume this journey of timber construction because we now want to have a look at the vulnerability points and get an understanding of what we should improve in order to deliver quality in this area. And so, bearing in mind that wood is an organic, natural material that has a certain specific characteristics, and we should therefore spend some time with Gianfranco Magri, a specialist in wood diseases, and discuss the relevance of the manufacturing supply chain and how we can preserve the quality of wood. Why is it so important to preserve this quality? There are many different measures that help us preserve timber from the very beginning, before it becomes a component of the wood houses. You have the floor. You were right. Along the wood supply chain, there are different steps, and processing of wood is just the first one. But every single step, like sawing, processing, storage, installation, wood is exposed to the attacks by wood-eating insects. They perform an important function in nature, that is to say, to recycle wood. If wood-eating insects eat dead wood, that's a thing, but when they start attacking human-made and human-engineered wood, then it becomes a problem. And so we need to come up with systems that ensure durability of wood and prevent insects from attacking wood. And this needs to be done in every single step of the entire woodworking process. There is no step of the entire pipeline that is exempted from this problem. So each step owner is responsible for the quality of the wood that is passed on to the next step of the supply chain in the pipeline. So quality must be preserved. As part of the wood processing step, the risks of wood-eating insects are very, very high, and there is a tendency to treat wood with high temperatures in order to prevent insects from attacking wood because they are modified at molecular level. However, there is a but. Wood strength resistance by so doing is reduced a lot. Consequently, wood beams that will perform a load-bearing function cannot be treated in this way. And maybe I can tell you a personal short story. During my professional life, I typically provide experts' opinion to expert opinions in case of claims, and I have found that almost all the infestations for carpentry's part mostly affect load-bearing beams. This means that whoever works alongside the woodworking supply chain is aware that they cannot be treated with the high temperatures, but they haven't adopted the most appropriate systems to ensure durability of wood. The real problem is that there is a lack of the culture of wood. We've been discussing this many times. We don't know exactly what we need to do. And the other point is that the legislation has some gaps in this respect. The law requirements have a lot of gaps. Law requirements just provide a few indications, but it's not as detailed as it should be. Let me And maybe you can share with us the measures that we should adopt to prevent this from happening. Well, let's now focus on the transformation phase or the processing phase, but the principle applies to all steps of the process. Three measures can be adopted and implemented to prevent wood from being attacked by wood-eating insects. Number one, disinfest the wood. We don't just need to rely on the fact that the previous step of the process did everything that was necessary. So in order to be on the safe side, we can apply heat, not high temperature, but a heat treatment with low controlled temperatures, let's say in thermal inductive chambers, 70, 75 degrees in chamber, and then 50 to 55 degrees maximum at the core of the beam, so that the strength, the mechanical strength, is not jeopardized. Once has been completed, wood must be put under safe conditions by applying wood worm killing substances. And the third measure that we can apply is to protect the production factories with UV lamps that capture insects and that ensure a permanent disinfestation within the manufacturing plant. With the application of anti-woodworm products, a whole new field opens up because maintaining this has a cost. And since the law requirements are not so detailed, unfortunately, very often we are exposed to kind of opaque behaviors, sometimes because of ignorance, some other times because of people wanting to be smart. A classic example that I often encounter in my job is this one. I have applied the woodworm killer, so rest assured that the wood I'm selling you is compliant. However, wood killer ensures protection of wood for 2 years and not longer, because later than that, oxidation no longer permits protection. So when you get the timber and it is installed, you may be exposed to visible infestation that were concealed because the biological life of woodworms has a certain time. The most common one is 2 years. But if the woodworm killer has been applied on the timber 4 or 5 years earlier, of course the timber will no longer be produced. And so the flitting about of insects, which shows that the infestation can only be seen when the timber has already been installed. So at this point, we need to think about this. Maintaining wood protected and repeating the application of woodworm killer every 2 years is a cost, but is it better to save that cost and pretend that nothing will happen, or is it better to preserve wood and quality? When wood is installed in the construction site and then flitting about of insects occurs, what happens? It's like having light matches in your hand. Who gets burnt out of it? It bounces back against us along the entire the process of the industry. Everybody will be suffering in terms of reputation, in terms of image. So maybe it's worth being more careful in preserving the material from the very beginning. So there is a need for being supported by stricter and more stringent legislation. That's because legislation usually helps educating in the various industries. Yes, because in the training pathways, the culture of wood is not really addressed as a topic, and therefore operators and end users do not have the critical instruments and notions to understand whether they are using a compliant wood or not. So a long way is still to go in terms of legislation so that we can make sure that the starting material is suitable for timber constructions. Nowadays, this is possible because there are available technologies, and on top of that there is also common sense, so the ability to make assessment, make appraisals at the beginning of the industry pipeline. Once the timber that has gone through all these steps in terms of preservation, treatment, and protective applications, once all these steps have been completed correctly, then I can be comfortable and confident that we will not run into any problems. So the cases of this infestation are traceable back to an incorrect treatment before the installation and the deployment of wood in the construction site. Thank you, Gianfranco. When I opened this conference, I said that I was reading a very nice quotation a few days ago, and I'm an architect by background, and so I often go back to projects, and that mindset has stayed with me also in my career as a journalist. And as I said in the beginning, I was impressed by quote by Emilio Ambat, who was the first one to talk about green architecture. The quote reads, "Each building is like an intrusion in the vegetal world and is a challenge to nature, when architecture must be conceived as a pact of reconciliation between nature and construction, by designing buildings that are innerly blended into the surrounding environment, that they cannot be disentangled from one another." I think this sentence is beautiful, is amazing, very revealing, and it tells it all. We've listened from architect Giachino what the potentiality of timber construction is. There is a new concept nowadays that we can rely on engineered wood, like ex-lam wood, resistant wood, provided that all the conditions that Gianfranco Magri explained are met. So it is absolutely comparable to the so-called traditional materials. And of course, we could also think of a hybrid product, for example, for the foundation of a construction, plus other smaller technological measures. What Emilio Ambatz tells us is to opt for an ecological architecture, because this is one of the ethical values that the city planners, the building planners can contribute for a planet that really needs such measure such a contribution. In terms of building heritage, and that is which is responsible for 40% of the hazardous emissions, well, wood can certainly bring about this remarkable substantial contribution. That's why we think it is so important to really trace a pathway for quality, so that timber constructions, as all buildings, have a life cycle of at least 50 years, and in addition can also promote this added value because they are able to store CO2. They are CO2 storage points. What the piece of wood used to do in nature can also be maintained by a building. Then we should also talk about procurement processes. We don't have the time to do that today. However, let's remember that when we talk about construction timber, we talk about PFC, FSC, forests that are maintained with sustainable criteria, and we also speak about forests and that are well preserved. It means that for trees and plants are cut with a targeted project, and there are a number of measures that really ensure the quality of the raw material, also for those who will use it in the construction industry. So the pipeline of the industry is long, is very comprehensive and complicated, and also relatively new. And going back to the president of Gruppo Qualità Legno, with whom we started and opened today's conference, I can tell you that he has accumulated some experiences in these 20 years of timber construction, just like engineer Arata too. So I would like to be very honest and also underline, highlight the problems that are still present in timber construction. As I often tell stories about this sector, I am confronted with people that one of the problems of timber construction is that they use a traditional approach to wood houses. Basically, they translate the traditional brick-made houses and just turn the same project into wood. And this is the biggest mistake that would be done, because there are some strict rules that tells us that the preservation of wood once installed needs to be dependent of previous preservative treatment. Is this correct? This is more than correct indeed. When you say that a planner translates from technique to wood-based technique, is that sometimes they're not even good at planning with the traditional technique, and so let alone what could happen with a wood made work. Residential housing is made of a lot of improvisation, I would say, also good willingness. I can certainly admit that nobody has bad intentions. However, the previous structural system that we used was able to offset the errors made by the planners, and the quality was low, whereas now we aim at a higher quality because we want a minor impact on the environment, and so we need to pay more attention to the planning of the structures. Absolutely. Thank you, Engineer Arata, for this first answer of yours. I was talking about this with architect Giachino. The point is that unlike traditional building, wood shows criticalities very soon, whereas it took a lot of time for Morandi Bridge to show all these criticalities, but it ultimately did. So if we build well, we can be confident, but if we don't do so, it is very hard to reach accomplishments. I mean, I would not list all the construction sites that need being fixed, but a new set of golden rules are emerging through this experience. Is it correct? Yes, unfortunately, there are many problems emerging on this front. We need to start from the concept that we use fir wood, spruce wood as raw material, red or white spruce, and its durability is very short. Poplar is the only one that lasts less. So the raw material that we are using is poor in terms of durability, although it features many other benefits and values. So we are confronted with a problem that needs to be faced, needs to be tackled. In recent times, it hasn't been managed correctly and properly. You mentioned the experience of the earthquake in Abruzzo. Unfortunately, it was a negative experience, so much so that in January this year, the municipality of L'Aquila has decided to demolish at least 10 projects of the Progetto Case. So these projects will be completely demolished. Are you referring to the parts made of wood and not the other part that he was mentioning earlier? No, also some buildings that were made of not wood but with steel will also be demolished. Many of the projects that will be subjected to demolition are are actually the timber construction. They had already suffered the first mutilation with the balconies that were almost falling off. They developed problems. Unfortunately, there were no casualties. However, it was a serious problem. And so these buildings were mutilated. After years of blocking them, the decision was made to remove the balconies. And instead of the entrance door leading to the balcony, railings have been installed. Now you can overlook the outside from it, but it looks really ugly. And that was actually a failed experiment, unfortunately. Why do you think it hasn't worked out successfully? Because of the lack of competences on behalf of those who handled the construction site? Maybe if we can say this clearly, will help us doing better things in the future. Well, let's say, aside from the specific case, let's say that there has been investigations. I think the justice is doing its course. However, we were back then in 2009, and that was the first occasion for Italy to use the cross-laminated timber system for the first time. The previous year, we had made all the experiments with engineer Ceccotti, and it had been demonstrated with the building of Project Sophie, tested in Japan. It had been demonstrated that the projects would be potentially viable. And the first occasion was in Aquila after the earthquake, but cards were not played properly for a number of different reasons that we don't want to investigate into. Surely the lack of knowledge has had an impact in that. That project, of course, dates back in time compared to the situation today, where much progress has been made. We are here at Xylexpo, and so technological progress has also advanced. So thinking of the timber construction industry and supply chain, and thinking about the concept that architect Giachino just mentioned, that is to say, planning locally and building globally. This is possible only through the technologies that are available nowadays. We can even see this when we develop our reports in the various companies. I can see this when I go out there as a journalist. There are companies that provide these materials, and in the past few years, there is a big imbalance in the manufacturing factory where you just find 2 or 3 operators managing many machines, and then the technical department that is populated with many engineers or technicians that interact with the machines to get the machines produce precise and accurate pieces. We were used in conventional building to measuring everything in centimeters, but nowadays a building is made up of different pieces, just like a puzzle, and we have a connection from piece number 1 to the very last piece of the building. And this is certainly fascinating on the one hand, but on the other hand, it also brings about a number of requirements. A dry construction site is safe because most of the elements are made off-site, and there are also many advantages in terms of safety at work, specifically in construction site. Well, you just hit the point, because this is kind of a Cinderella of all the thoughts that we are sharing here today. Building a wood-based house with these millimeter precise systems means that you dramatically reduce the construction site processes. This is an additional element that improves quality, and the dangerous stages of work in a construction site are reduced. So how long does it take to build a house? It rains, it snows, there is a hailstorm, storm. We have no idea. So having scaffolds erected for a long time, you are mounting something, a bolt is not been fastened properly, any incident can happen. Even if you pay the highest level of attention, well, this exposure reduces in time and also reduces in terms of people exposed to the hazard. The likelihood of something bad happening also reduces dramatically. We have recently spoken so much about that in construction site. Well, wood or timber construction is definitely a safe environment. And this is not a little, it is another advantage that it's worth highlighting alongside the comfort of living. There are many studies available in many Italian universities that we mention in the magazine, Web and Magazine. And we often refer to this research conducted on the comfort of living granted by timber. Compared to other material, it has been proven that timber increases the comfort of living, and there are medical technological studies that have proven that living in a shell of wood timber provides an important level of comfort that can also be measured compared to an environment that has been built with inert materials or other materials that can be more irritating as you measure the various vital parameters for the individuals that are subjected to these experiments. So after this review on timber construction, and you did very well because you provided us with a very in-depth feedback despite the short time available. So after this review, let's try and come to a conclusion by leaving a lot of positive feelings with everybody here. It's important to look at this large industry and all its potentialities in a realistic way. So what are your desires looking at the buildings of tomorrow? Well, I have at least three in my mind, even more, to be honest, but time is not on our side. Well, somehow my first desire when I think of timber, wood, I have been dealing with this topic for the past 30 years and I've always repeat the same things, and I think that things sometimes never change. But number one is to just get rid of some tried common misbeliefs, misconceptions related to wood, like wood is a natural material, wood is a earthquake proof, and Marco told us why it can be anti-seismic because it doesn't have this property on its own, or wood is an ecological material. There are buildings built here made with timber that comes from the other side of the world. So I wonder how environmentally friendly such a process can be. So there is a lot of banal misconceptions surrounding wood. Unfortunately, companies still utilize these concepts. So this is my first desire, to put an end to this stage and talk about timber and wood in constructions in a more evolved and refined way. The second aspect concerns something that you already mentioned earlier, and that is to say that finally we realize that wood is a material of biological origin, and so it is subjected to degradation unless it is treated properly. Some companies say they don't want to treat because otherwise if they declare that it has been treated, then they don't sell as many houses as they want. This is another misconception. We've seen examples whereby after a few years, major degradation has occurred, and there are so many examples of that. This has to stop. Nowadays, technologies allow us to prevent all of this degradation. Just like in a car, we have dozens and dozens of sensors that tell us when the tire is flat and when anything is wrong. It is unthinkable for a building of million of euros worth that there are no sensors that detect the humidity of timber in it. This is absurd. So you can design your building, a timber building, in the best possible way, but then there are not these mechanisms available. So I hope that the future will be less uncertain. I spoke with a friend from the sea and air. Technologies make everything possible, but research requires investment. So there is a need for investment and research. And the last topic that I'd like to mention, and those who know me already have guessed what it can be. We discussed this during the Week of Wood in Rome at Tor Vergata University. The third aspect has to do with education, training for planners. At universities, there is no teaching concerning timber design, how to design with the timber, not so much from the point of view of structural principles, but also technological principles. Number one is always reinforced concrete, then they speak a little bit of steel, and if time is left, then also timber is addressed. We need to teach wood, and probably we need to change the teaching and education models in universities towards a model that has more interaction. And nowadays there are forestry sciences where you address wood in terms of technological material, but nobody really connects with each other. So there is a need for integration amongst different disciplines if we really want to make a leap forward. We need to overcome this model. Well, a small step has been taken, I think. You, as a scientific committee during the week of wood, a dossier, a file about wood is being developed. We have made two important steps forward. I was witnessing this week of the wood. I was moderating it. We had a list of 50 different specialized speakers in the industry, and we spoke about forestation, and then we ended up addressing timber construction. And then we have also invited and engaged many Italian universities to deliver their speeches and contribution at this Week for Wood. And it was an important step for us to make, because we want to implement the teachings of this masterclass. Around the table of the final masterclass, there was Politecnico di Torino, IOV in Venice, from Venice, Tor Vergata University, and this is definitely another accomplishment. As you rightly said, that this is another key step that needed to be taken, because if progress that is made remains isolated, it cannot be called a fully fledged progress. Today, in the era of digital revolution, we need to take advantage of the tools that we have available, and this wood-related dossier will be circulating in major newspapers, so hopefully the messages will get disseminated in the same direction you just mentioned. Well, GQL aims at becoming a sort of a carrier, a link between the research that it's made in Italy and universities that sometimes remains relegated to individual universities. We are trying to bring the various universities together and create a common leitmotif and thread. Something about education. Nowadays, there is a lot of discussion about circular economy. Current buildings have nothing to do with the concept of circularity. I teach a lot to my students about wood-based buildings that can be mounted, installed in a dry state, but this is a half-lie because in the past few years we had to disinstall and dismantle the timber constructions, and it's not easy at all to dismantle them also because they are not always 100% dry. Sometimes we have footer or screed that are not dry, outer insulation that are not dry, and when you have to demolish all these parts, the demolition works become complicated, more expensive, and paradoxically more pricey than demolishing a normal building, which is really a paradox. I have to say my mea culpa, because I've always sold the image of timber constructions being able to be mounted and dismantled easily. So we will want to talk about circular economy of the wood industry, the topic regarding the design of various fasteners and connections needs to be revised. This also clashes with the building technical rules that provide indications that contradict the whole concept. So this needs some revision too. And before I close, I would just like to make a final comment on Ambat. I had no idea you would quote him. Ambat is very dear to me. I met him in 1997, 1998 in Turin, because he was involved in the Environment Park project where my office was for 25 years. When I met him, he was dressed in white, wearing a white hat. He almost looked like a drug trafficker from South America. But I would also like to quote him with a wishful quote, "The green on the grey." That's great. That's amazing the way you have concluded your contribution. So we have received a lot of interesting input here. So our desire is to keep on growing in this industry. Through the growth, we can propose natural buildings, truly natural buildings. What you just said reminds me of the concept that is now very much evolved of the cradle to cradle. So we no longer speak of certification that accompany products or buildings from the cradle to the graveyard, but actually to the cradle, from the cradle to the cradle, for the rebirth of all these materials. In current days in France, for example in Paris, some buildings are being decommissioned and then hubs are created where you can go and collect the windows that have been dismantled from those decommissioned buildings. That's the direction we should go. That's the wish we should all aim at. We discussed this a lot during conferences at Ristruttura, speaking about local materials and providing projects for the Italian forests industry, so that local wood, local timber can be made available to planners and designers according to a leaner planning process and also closer in terms of the territory. So there are many different steps that can ensure having consistency in certifications of true circularity. As you just mentioned, building a timber construction is different, is more complex than building a piece of furniture. And it can't be just the timber, because foundation will remain in reinforced concrete, XLAM timber, so many other aspects that we could touch upon. In other contexts, I learned recently that some XLAM made slabs can also be reutilized. So there is a possibility for reuse of the product with the same original function. And when it is not possible to recycle it 100%. Last minutes will be dedicated to Gianfranco Magri, and let's try and close on a positive note because this is an industry that needs continuous growth. Yes, this is an industry that has a lot of gaps to be bridged. In this industry, we move around by floundering and improvisation. I said earlier that there is a need to bridge knowledge gaps, and I was referring to the fact that educational pathways should foresee a study in depth into knowledge from the beginning of the pipeline. Of course. And last but not least, I would also like to give the floor to engineer Arata and ask him about his future wishes and desires for construction. Well, going back to what we just said about recycling and natural houses, I need to be honest here. Oftentimes, clients come to my office and they tell me, I want a house like the one you build and design because I want a healthy environment, I want to use natural materials, hemp. Um, and honestly, I have never conceived timber houses just in terms of using recyclable and natural materials. Of course, we can do that. We no longer use Ethernet, which is already a big accomplishment. I remember my uncle using Ethernet and cutting it with flexible cutters. Anyway, I wouldn't focus on that concept because there are many other benefits that are to be reaped even before building a timber construction. First of all, I may also say that my wish is just to cut the CO2 emissions in the atmosphere. And for sure, no doubt, this is something that is a consequence of many other benefits that we pursue by establishing and by designing low energy consumption houses. For example, let's go back to insulation and airtightness, and we are able to decrease by 10% the energy demand of a house, of a household. This is already an advantage. Let's make an example, a single or double family house with a classic 35 kilowatt boiler. Well, we may have low powers, which is like the same power utilized by an air blower at the hair salon. By so doing here, we can use an air ventilation system, an air exchange system, because if you have air tightness in the house, you need to exchange, you need air exchanges, so you don't install heating systems anymore. People get afraid and they abandon the project. But there is a point in it. So we offer a air exchange system which we can use to provide air conditioning. Air can transport 2 kilowatts, and you don't need to use water pipes, a radiator. It's a completely different system. You can provide both warm and cold, whereas with air you just need to need to use just heat pumps, and then you can only provide cold air. So with air tightness, you can obtain a much more comfortable living environment with fewer CO2 emissions, a healthier environment because air inlet occurs only at one point in the house where you can put filters and ionizing devices to kill all the germs and bacteria. And so ultimately, you have a living environment where my family would live certainly better. One thing that I like to do in my projects, and I really care about it, as it is mandatory since 1989, is the abatement of architectural barriers. So if we link with one thread all these advantages, safety because the construction site process is shorter, comfort, abatement of architectural barriers, then what would be the purpose of future building and construction? Will it be renovation? Maybe because we need to renovate old times and build new houses in the suburbs? Well, I don't know. Rather than a renovation of the building heritage, I think that with the new legislation, the one approved in 2013, is more oriented to the demolition of buildings. We have many ugly buildings. We will keep the good ones, and then we'll see again who stays in the so-called good buildings if they're not modern, because if everybody's living in with bad comfort, we are all ready to accept it. But as soon as you experience a comfortable living environment in a modern setting, then we all would like to have it. Let's make an example of building blocks, the ugly building blocks in the suburban areas, so many of them. Well, maybe you have a building block housing 25 households, families. I cannot stimulate these families to fraction their properties. That's already a problem. However, I would take that building block, demolish it, and as I demolish it, a factory would already have been producing all the pieces of the new building with numerically controlled machines. The foundation is ready of a quick time. The trucks arrive to the construction site, and we start elevating the new building and mounting it up. After 3 months, let's say, we have a normal new building block with zero energy consumption, with no architectural barriers. We would have removed the famous 5 steps at the entrance, impeding everybody from reaching the elevator. Little consumption demand is covered by 4 photovoltaic panels, so that it becomes an island, energetically speaking, standalone island. We would have less noise. As you know, timber also has the property of conducing less noise. And then you can come up with all the various perfectioning interventions. And so over a very short amount of time, I have a new living environment, even looking beautiful from the outside. That's a thing that the architect would take care of. So, but there is still a missing piece in the legislation, and it is to say doing the same thing that they do in the Netherlands, taking those families out, putting them in a residence and calling them back in the residence when everything is ready. And that would also increase the perception of increased and improved comfort in a timber construction. We are told that people living in timber houses no longer want to exit their places, and this is no longer an issue anymore. We have smart working. Let me conclude here by wishing everyone good wood and good cultural wood.